Hi everyone, my name is Heather Z and I am a specialist in the Azure Networking Global Black Belt team. In this video, we will show how we can use a DMZ VNet in a virtual WAN to secure all internet egress traffic. We will not walk through the basics of building a virtual WAN and components such as the VPN gateway, as these steps are well documented. Instead, we will focus on configuring a default route pointing to the most commonly used active-active virtual firewall deployment, and show how this default route is redistributed across virtual WAN. So let's get started. The scenario here is an organization which has requirement for all internet destined traffic to be inspected by a pair of active-active network virtual appliance firewalls deployed in a DMZ VNet. The architecture is a multi-region vHub design, west and east, where we have branch connected by site-to-site VPN. Spoke VNets are connected to the hubs, and of course, the DMZ VNet also has a virtual network connection to the hub. The expectation is flow 1, or local VNet originated traffic, will hit the DMZ firewall before egressing to internet. Similarly, flow 2, which is originated from OnPrem, will also need to hit the active-active MVAs in the DMZ before egressing to the internet. Finally, flow 3 represents a remote VNet originated traffic, which is not a common design pattern since most customers will want to egress via a local region. Nonetheless, we will show this as a possible requirement for an organization. So before we go to the portal, let's highlight some of the specifics in the demo. The organization is using RFC 1918.172.16/12 block for Azure. On-premises is using the 10/8 block as well as the 192.168/16 block. The branch is connected with IPsec VPN terminating on a Cisco CSR 1000V, and BGP is used for dynamic route exchange between vWAN and on-premises. The active-active MVAs are FortiGate firewalls sandwiched between public load balancer and internal load balancer. Traffic egressing the internet will use the public IP address of 52.149.153.228. Please make a mental note of this address as it will be important in a demo. Also make a mental note of the ILB address, which is 172.16.136.68. Now let's go to the portal. We start with vWAN Insights to confirm the topology that we are building off of, which is a vWAN with two hubs, east and west. In west, we have a single spoke VNet connected to the hub. And in east, we have the DMZ VNet, a spoke VNet with the VM we showed previously, as well as the on-premises site-to-site VPN. With this, we have any-to-any connectivity, so let's validate it. Let's go to start with this VM 172.17.04, which is the East VM. and show that we're able to reach west, which is 10.172.24.0.4. Very good. And it looks like my on-premises connection has timed out, but nonetheless, we will ensure we have reachability to it. Very good. So we already tested connectivity between west and east, but let's now test it in the opposite direction. Oh, whoops, wrong one. Very good. And let's test to on-prem. Very good. We have any-to-any connectivity. Okay, so now with these two VMs, let's see what the internet connectivity looks like. We'll issue curl ifconfig command, which shows me that the address presented to the internet via curl is 21.21.20.178, which is the IP address associated with this VM, the public IP associated with the VM. So it is going directly out to the internet, not through the firewalls, as we would expect, because we have not yet configured it. Similarly, on the West VM, we see it is presenting itself to the internet as 23.101.203.207, which is this West VM's public IP. Now, let's double check that against effective routes of each of these NICs, just to make sure that it makes sense. So let's go to 172.17 interface and check the effective routes. And what we see here are the routes which are learned through virtual WAN gateways. It's learning the on-premises 10/8 prefix, well, there's /24, but the 10 range and the 192.168 range. But the important line to see here is right now it has the default configuration of 00 default going directly out to the internet. And that is consistent with what we saw here with the 2121 address. Let's check this against the West spoke VM. We see the same thing, and again, 0/0, we're going directly out to the internet, not going through the DMZ as we would expect. And that is consistent with what we saw via the curl command earlier. So now let's go ahead and finally configure virtual WAN for default route so that all internet destined traffic from the flows that we previously described will go through the DMZ. To do this, we go to the virtual WAN blade and we select the hub that is connected to the DMZ first. So we go to the East hub, then we go to the routing blade, and in the routing blade, we are going to configure a static route for 00 in this default route table, pointing to the internal load balancer. We need to give the route a name, so we'll say east to internet. We're in the East hub right now. The destination prefix representing the internet is 0/0. So 0/0 is bound for the internet. And we're going to force the traffic across the DMZ connection, that VNet connection. And the next hop, as we mentioned, is the internal load balancer address, which is 172.16.136.68. We need to specify the next hop IP on top of the connection. The connection directs you to the VNet, and now we need to specify the next hop, which is the load balancer in this particular case. So we confirm, and then we create this. So while this is updating the route table, let's just go back to the diagram and make sure we understand what we have done so far. What we did so far is we created within the East Virtual Hub a static route pointing to 00, pointing to the internal load balancer. Because this is a load balancer, traffic now destined for the ILB will be selected by the load balancing algorithm. It will select one of the two firewalls on the way out. And because these firewalls are back-end to the public load balancer, and we have used this, we have associated this address of 52.149.153.228 with the public load balancer, and the back-end of the public load balancer are the addresses of the active-active FortiGate firewalls. When traffic goes out, it will use this address of 52.149.153.228, and that is how traffic will be seen on the internet from Azure. Azure will now use the address of 52.149.153.228 for egress traffic, because NAT is required. We cannot go out to the internet, as we know, using the blocks of 172.16, 172.17, or 10.0. So with that, let us go back to our VMs and see what it looks like. If we issue the curl command again, we see that, in fact, it has changed to 52.149.253.228 for this East VM. So now traffic is going out using the public load balancer IP, meaning traffic is egressing the firewall, which is exactly what we wanted. So if we go back to the VM, the effective routes should also match. So let's refresh this. Give it a second to refresh. And we'll see that the route table also looks different. And indeed, whereas before we saw 0/0 with next hop of internet, now next hop is pointing to a gateway address, which represents the virtual hub. So traffic is now going through the virtual hub. Okay. So now we have validated flow number 1 is using the address of 52.149.153.228. In fact, let's do one other check with that. Remember we said we have that test VM, which you can still see in the background of the screen. I'm going to SSH into it and show you how it looks. So I'm going from 172.17.04 through the hub, through the internal load balancer, to one of the two active-active instance firewalls, and hitting this VM here, 52.183.63.77. So I can check by netstat the TCP sessions. And I see indeed this local host, which has this SSH session. This is the one established. It is coming from 52.149.253.228, or the public load balancer. So with that, we've proven again that traffic is hitting the firewall. Now that we've validated flow 1, let's take a look at flow 2, or traffic from on-prem. Now, traffic from on-prem will learn about the 0/0 default route that is advertised if we choose to propagate the route. One thing to know is 0/0 is a somewhat dangerous route to propagate. So within virtual WAN, we give you selective controls. So you can actually block the traffic from propagating across each connection individually. So let's first validate that the 0/0 that we defined is allowed to propagate across the site-to-site connection. And we do that by going into the site-to-site blade and checking that default route is propagation is enabled. So very good. So with that, let us go into the on-premises Cisco router. Session timed out. So let's make sure that even though we've allowed 0/0 to be propagated across that site-to-site connection, that it actually is being learned. And we see here, indeed, 0/0 is learned by BGP, and it is coming from 172.23, which is a gateway in the virtual hub. So indeed, 0/0 is being propagated. So if we do the same test that we did earlier, an SSH test to that test VM, the VM is an address that I've just typed in. Again, let's check this netstat command to prove that the SSH session is coming from the public load balancer address, which is front-ending the two firewalls. And indeed it is. Excellent. So we have validated flow 1 and flow 2. With that, let us go to flow 3. If I can find the VM. Okay. One thing to understand is 0/0 by default is not propagated across the hub. What that means is, even though when you define a typical static route that is not 0/0, that static route can propagate across hubs, but because 0/0 is such a special case, it does not automatically propagate, which is a good thing. So you'll see that the VM on the west is still accessing the internet directly, and we've proven that by this curl command. However, if we want flow 3 to go across the firewall, what we can do is do the exact same thing we did earlier for the east static route definition. So now we go to the west virtual hub. We go to the routing blade. We make the definition in the default routing table. We'll call this west to internet. Again, the destination prefix is 0/0. Next hop, we are going to choose the same DMZ VNet connection because that is where the firewalls are. And we will add the same next hop, which is the ILB. So again, what we've done is defined a static route, this time in vHub West, pointing to a connection that is in a remote hub that's connected to a remote hub. And with that, Spoke 1 will be able to reach the internet via this DMZ VNet complex rather than go out directly as it had been shown to do. So if we go to this VM, if we issue the curl command, we see that this also has changed to 52.149, 253, 228 when it egresses the internet. So now traffic originating from the west VM to the internet will also pass through the firewall. We'll do the same test we did earlier, which is SSH into the test VM. And we see that the single SSH session on this host has originated from the MVA, or has passed through the MVA because of the public IP address. So with that, we have addressed flows 1, 2, and 3, and have configured them to all go through the DMZ VNet. So there are two critical points that we need to mention about the MVA, and that's that the FortiGates, and in fact, most MVA firewalls do have multiple NICs. In this case, there's a trusted side and an untrusted side. For this static route configuration, we actually need to be sure that the untrusted interface of the firewall is not learning the 0/0 route that is being redistributed across the virtual hub. Because if the untrusted interface learns about 0/0 with the ILB as the next hop, you will have a loop. Traffic going out to the internet will hit the ILB. It will be processed by the firewall, and the firewall will dump it out on the untrusted interface, which sends it to Azure. But Azure sees that the next hop is 172.16.136.68 is the ILB, which will result in a loop. So this problem can be addressed in one of two ways. The simpler way, which is what we have done for this demo, is simply to disable propagating default route. If this is disabled, 0/0 will not be learned across this connection. And that is not needed by the DMZ VNet because there are no other VMs in the VNet and you have a static route pointing to it. Another way of addressing this problem, potential loop problem, is to override any hub learned route by UDR pointing to 0/0, pointing to the direct hop of internet. But the simpler way, in my opinion, is simply to disable route propagation. And by the way, if I were to show you the same edit VNet connection, it is obviously enabled on the east spoke. Otherwise, the VM in this east VNet would not have learned the 0/0 route, and we would not be going directly, we would not be going to the internet by the firewall. But this emphasizes the ability to selectively turn off propagation of default routes across connections, whether it's a VNet or whether it is a site-to-site connection, as shown previously. Another important point that we need to emphasize is the NVA OS has no concept of the Azure SDN or routes in virtual WAN. So it needs a little help to know which interface to send which traffic. So in the Fortinet, we will need to define some routes for the on-premises, pointing to the trusted interface, and the 172.16 block to the trusted interface. Because if these destination prefixes are not in the FortiGate routing table, when traffic hits the NVA, it will be dropped because after processing, it will not know how to handle it. Because remember, the NVA OS is independent of the routing in Azure SDN. So to summarize the steps of what we've done, we can configure secure internet access via DMZ firewalls with these simple steps. First, you deploy the active-active NVAs in the DMZ VNet by using the standard third-party partner templates. Nothing needs to change with virtual WAN. Now, with this DMZ VNet, you want to build connections to virtual WAN, and you're going to build connections to other VNets and branches. You want to make sure the DMZ VNet's connection is disabled for propagate default route, or alternatively override the untrusted interface with 0/0 pointing to the internet. You need to be sure that firewalls whose OS have no awareness of Azure routing have entries so that when a packet comes in, it passes through inspection, it will know how to forward the packet. In the default route table, in order to get the static route, you will create a 0/0 rule pointing to the ILB of the NVA as the next hop, but pointing to the DMZ VNet connection. And of course, if you have a virtual WAN with many VNets, you may have some VNets where you want to break out locally to the internet and you do not want traffic to go through the DMZ complex. In those particular VNets, you would want to disable propagate default route. So this 0/0 is not propagated to those VNets. And of course, it's very important to test and validate that 0/0 is propagated across the hub appropriately. And finally, optional step, as we did for flow 3, repeat step 5, that is defining the static route for 0/0 for remote hubs as necessary. So hopefully you found this video useful. With the steps shown, you should be able to take a standard third-party firewall and V8 template, deploy it in a DMZ, in a VNet, and supporting your north-south internet traffic originating from workload VNets or on-premises. Thank you very much.